Okay, recording in progress. So we'll go ahead and share the screen. All right, so I'll give you a little bit more in 5.3. I may come close to finishing 5.3, but if I don't, I still have next week to do that. We only have one last section, 5.4, for all of next week. So next exam is Friday the 19th. Okay, tomorrow's a holiday for Veterans Day. I know some people have the holiday today, but we don't. So I know some people around us are celebrating the Veterans Day today, but ours is tomorrow. So be that as it may. Okay, so I'll give you the quiz. I'll do some problems, and then I'll probably end early so that you can get going on the quiz. So here we go with the quiz, and I'll give you some hints on the quiz. So get ready with your screenshots and cell phones and all that stuff. And if worse comes to worse, again, you can always just watch the video later. Okay, here we go. I'm going to have to make it a little bit smaller so it fits screen. Okay, I think everybody can see this. Maybe I'll move it down a little bit. Okay, number one, sketch each of the following graphs and explain how each successive graph differs from the previous one. So I need to see all four graphs. Now I'll leave it to you whether you want to put four separate graphs or put two on the same graph and two on the others. Okay, I will say if you try to put all four in the same graph, it gets a little bit too crowded. Okay, so how about let's just say when you get to the point where two graphs start touching each other, then switch to another graph. So you may have 1, 2, 3, 4 different graphs, or you can probably get by with putting two on a graph. Like the first two, it's not that bad to put them on the same graph, but after that, it might be a little bit tough. Okay, e to the x, your basic exponential function. If you have no idea what it looks like, look back at your notes, look at the text. So g of x is negative e to the x. So what happens when you go from here to here? Then h of x is negative e to the x minus 2. So the x got changed to x minus 2. So what happens there? And then q of x is negative e to the x minus 2 plus 3. Okay, so four separate graphs. Okay, and just show what happens you need. So you start off with a basic e to the x. Then it looks like you multiply by negative 1. So what does that do, right? And then x gets changed to x minus 2. That there's a specific rule for that. And then this whole mess plus 3. So you should know what happens to that. Okay, 2. Log base 2 of 5x minus 21 equals 4. I'll just give you the hint to unscramble it. Write it without the log. If you can write it without the log, then it becomes very straightforward. Okay, how do I get rid of the log? Hint is always start with a base, right? So which is the base, which is the exponent, which is the answer, then it's pretty simple. Okay, 3, I haven't yet told you how to do this kind of problem. 2 raised to the x minus 1 equals 3 to the 2x plus 3. I'll go ahead and say that you take the natural log of both sides, take ln. Once you do the ln, the exponents come down, and I'll show you an example of that right now. If you want to put that in your notes, you may, or listen to the video later. So to solve this kind of thing, take the natural log of both sides, you put an ln here and an ln here, and then the exponents come down. And I'll show you an example of that. Okay, so that's the quiz, due at 11:59 p.m. tonight. So you have plenty of time to do that. Open everything, open book, open note, open discussion, but as usual, do the problems like we've demonstrated in class. So some of you have been working it out, but you don't work it out the way that we did it in class. I need you to do it the way we do it in class. Okay, and so I know it's a Thursday. We normally have quizzes on Friday, but this is the quote unquote last day of the week, right? So quizzes today, and tomorrow we'll enjoy our Veterans Day holiday. If I can find it here. Here we are. Yeah, so go ahead and mark this off. Okay, so that's the quiz. Now I'll start the lecture. Okay, so I'll do more stuff from last time and eventually show you problems that's like the quiz. Okay, 39, the original problem. 39, ln of 2 minus x equals 4. Okay, so to get rid of an ln, you exponentiate. Now here's one thing that's a little bit different that sometimes students mess up. This is not a multiplication. So do not divide by ln. There's no such thing as that here. Ln is a function. To get rid of the ln, you exponentiate. And the way you do that is you put an E sunken down and to the left. So see how I kind of went down and put the E here? Okay. That way the E and the ln are next to each other and they cancel each other out. So I have 2 minus x equals e to the fourth. Subtract 2. It looks like this. Negative x equals e to the fourth minus 2. That's negative x. I just want x. So I multiply both sides by negative 1. Okay. And to multiply an expression like this by negative 1, all you do is turn these around. So e to the fourth minus 2 times negative 1 becomes 2 minus e to the fourth. Okay. I always want you to give me the exact value, and then you can use the decimal fraction later if you want. So this is considered exact, 2 minus e to the fourth. So you must give me this on every quiz, homework, exam. Okay. And then optionally, you can put this, because this is only an approximation, right? 2 minus e to the fourth. Let me show you that on my calculator. 2 minus second function e to the fourth. Whoops. 2 minus e to the fourth, negative 52.598. I decided to call it negative 52.60, 52.598. Okay. Okay, 43. 2 ln x equals ln this minus ln this. Okay, this minus sign tells me I should write it as ln of a quotient. So it's ln 4x plus 6 divided by 2. And I'm allowed to bring this 2 up, power property, right? Coefficient of 2, make it climb back up. So now it says ln of x squared equals ln of a quotient 4x plus 6 divided by 2. And now again, to get rid of the ln's, I exponentiate both sides. Do not divide by ln. There's no such thing as that. You exponentiate. That cancels these all out. Then x squared equals that divided by that is 2x plus 3. So now we're good. Now it's just a algebra 1 problem, essentially. Okay, throw these two guys over. X squared minus 2x minus 3 equals 0. Factor, x minus 3, x plus 1 equals 0. And here's a tricky thing to watch out for. X is 3 or negative 1, but you have to recall, we can only take the log of positive quantities. Okay, so if I plug in negative 1, ln of negative 1 does not exist. You can't take ln of negative 1. Okay, so ln of negative 1. And once I say that, I seem to contradict myself, but not really. This is a complex number. It switches over to a complex number. There's no real number that makes this a true statement, ln of negative 1. Okay, so you can only take the log of positive quantities. So I keep the 3. If I plug in 3, it looks like I'm good. So x is equal to 3. Okay, here's 45. ln this minus ln this equals ln 5. Okay, so the hint for this one is I notice that there's a minus sign. So what happens when I have ln of something minus ln of something else? I make it into a quotient. Ln of this divided by this, right? That's one of the properties of logs. You can put those properties of logs on your formula sheet for the test. So ln of 2x minus 1 divided by x minus 1 equals ln of 5, okay? And again, to get rid of the ln, you exponentiate, you put an e down like that. E to the ln blah, blah, blah equals e to the ln blah, blah, blah. And now the e and the ln's cancel each out. So to knock out an ln, you do an e, and to knock out an e, you do an ln. Okay, and once I get to this, then it's hopefully more comfortable, right? 2x minus 1 divided by x minus 1 equals 5. Okay, multiply by x minus 1 to get rid of the fraction. So these cancel out. 2x minus 1 equals 5x minus 5. That should be pretty straightforward. Subtract 2x, and while I'm at it, add 5. So these cancel out, these cancel out. 4 equals 3x. So final answer, x equals 4/3. And 4/3, quick check, if I plug in 4/3, it looks like I'm good. I'm not taking the log of any negative quantity. 4/3 minus 1 is 1/3. So we're still good in that circumstance.
With that said, like back to what you said on 43, like what confused me is that like if you plugged in -1, it would no longer be a -1. But that's saying that ln 2 ln x equals ln x squared. But it starts with 2 ln x, so I guess you just assume you just work with the original problem.
Correct. Exactly. Good point. If you start off with -1 here, you're no good. Even though if the original problem started out with squared, then you would be good. Okay. So this property only holds as long as x is already a positive quantity. Okay. So yeah, we're always going back to the original. 47 is very much like the second quiz question. So if you looked at question 2 in the quiz, you have absolutely no idea what to do, I'm almost telling you how to do it. Okay, so log base 3 of whatever, okay, unscramble it. By the way, that's my own terminology. I say unscramble it. That's not really mathematical, but I like it. You know, write it without the log. So, oh, I see log. I'm scared of logs. I don't like logs, right? So get rid of the log. So start with the base. The base is 3. You go across the equal sign for the exponent, 3 squared, and you come back in for the result. Okay, so one more time, 3 to the second power equals the thing that's here, 2x squared plus 17x. Do the exact same thing in the quiz and you'll get it. And there it is. I unscrambled it. I don't have log anymore, right? In case you say, man, I don't like this log stuff. But there it is, no more log. Okay. So my strategy is, you know, get rid of the log. Why have the log when you don't want to? So there it is, no more log. Okay, 3 squared is 9. So I now have this. It looks like I have a quadratic equation. So subtract 9 on both sides. And quadratic formula. So negative b plus or minus the square root of b squared. 17 squared is 289. Minus 4 times a, which is 2, times c, which is -9. So there's going to be a double negative here. So it's a positive. And this is scratch paper. 289 plus 4 times 2 is 8. 8 times 9 is 72. Divided by 2a, 2 times 2. 289 plus 72 comes out to be 361. Divided by 4. Believe it or not, the square root of 361 is exactly 19. So I get rational solutions. -17 plus or minus 19 over 4. Okay, so -17 divided by, -17 minus 19 is -36. Divided by 4, it's -9. -17 plus 19 is 2. 2 divided by 4 is 1/2. Okay, now what about throwing out stuff? Okay, so do I throw out the -9? Not in this case. See, the -9 isn't the issue. The issue is, am I taking the log of a negative? If I plug in -9 here and here, you actually get a positive quantity. So I keep it. Okay. You can punch it in your calculator, but -9 squared is 81, right? 81 times 2 is what, 162? And then 17 times -9 is 153, I think. So it ends up being positive. Okay, -9 we keep. And 1/2 is clearly positive because everything is positive. So I don't throw it out an answer just because it comes out to be negative. I throw out an answer because I might be taking the log of a negative quantity. That's no good. Okay, so that's what's happening here. Okay, 49. The original says 4 to the x equals 3. 49. 4 to the x equals 3. Okay, now be careful. It's not 4x equals 3. And I'll just anecdotally say this. Okay, so I know student tricks. Hey, I was a student before, right? 4 to the x equals 3. I've had students that just say, well, I don't know how to do that. I'll just kind of slide the x down and make it 4x equals 3 and solve x equals 3/4. No. You're not going to get credit for that. Okay, I'll just kind of cheat and, you know, slide this down a little bit, make it 4x equals 3. I know how to do that. No, you don't get credit for that. It's 4 raised to the x power equals 3. So if you try that trick on a test, I'm not going to give you credit, right? The trick is to take the natural log of both sides. You could actually take log base 10, but I want you to get comfortable with the ln. So you ln both sides. Once I have the ln, that exponent gets to drop down. X ln 4 equals ln 3. Divide both sides by ln 4. So x is ln 3 divided by ln 4. And on the calculator, it's roughly 0.7925. Again, on the test, you must give me this, or quiz, or whatever, and including today's quiz. You must show me what's called the exact answer. Exact answer means leave ln as ln, leave e as e. Okay.
Or we could just use log, right?
You could use log, but I want you to use ln. Okay. It'll
On
set
the
you up.
quiz and tests.
Yes, it sets you up for calculus.
Okay.
You're almost never going to use log. So on one hand, yes, you could use log, but since this is pre-calculus, we're getting you ready for calculus. And in calculus, you almost never use log. You almost always use ln for some reason, which I can't explain now. But your calculus teacher, hopefully next semester, will teach you all that. Okay, I'll digress even more. I've actually seen calculators that only give ln. That kind of tells you the importance of it. You would think, you know, oh, log base 10, that's more important than log base e. Not for calculus. Okay, there are some calculators that don't even have this button, but you cannot survive without the ln button for some reason. Okay, so yeah, please use the ln. I want you to get used to it. You might be uncomfortable now. Say, what's this e stuff, the 2.718? I'd rather do 10. You're right, but I'm setting you up for calculus. In calculus, you much prefer to use the natural log. So I want you to get used to that now. Yeah, you may not understand it now, but hopefully your Calc 1 teacher next semester will teach you about the advantages of having e. Anyway, so ln both sides. So technically, yes, log would work, but I want you to use ln. Now x comes down. So anyway, yeah, ln 3 divided by ln 4 is 0.7925 on my calculator. Let me show that to you. There it is, 0.79248. I call it 0.7925. Okay. And side notes, you might say, oh, can I cancel the ln? The answer is no. And the reason why you can't is because you can't. Okay, I know that sounds weird, but what is 3/4 as a decimal? Well, I know 3/4 is 0.75, right? Well, it's kind of close, but it's not the same. Okay. You might also say, is it ln of 3/4? Like, is it that? And the answer is no also to that. And the reason why it's not the same is because it's not the same. Okay, if I literally try ln of 3/4, again, you'll see something different. Maybe I should type it in correctly. Now, ln of 3/4, it's not even close, right? So when you get something like this, you might be tempted to do something with it. Don't like cancel the ln, or maybe I can do ln of 3/4. No, you literally have to just type it in exactly like this for your answer. Okay. Okay, 51, please. The original is like this. E to the 2x equals 3 to the x minus 4. Okay. And the thing about these problems that we don't like is that exponent. Excuse me. So ln. ln both sides. On this side, the ln and the e even cancel out. So forget about it, just 2x. Here they don't cancel out, but you can bring the x minus 4 down. In parentheses, by the way, make sure this is parentheses. And that's a hint for the test. The quiz question. The third quiz question, make sure that you put parentheses around the exponent. Okay, now I want to solve for x. See, this equation doesn't have those exponents floating up there anymore, right? I don't want it floating up there. I kind of want to pull it down, right? Okay, distribute x ln 3 minus 4 ln 3. Get all the x's on the same side. So subtract x ln 3 on both sides. It looks like this. Factor out the x and divide by the factor. So there we go. -4 natural log of 3. And ln stands for natural log. So you might hear me say ln, but sometimes I'll say natural log just to remind you it means natural log. So -4 natural log of 3 divided by 2 minus ln 3. This is considered the exact answer. So you need to give me exact answer. And that includes quiz question number 3. Show me the exact answer and then a decimal approximation. And by the way, if you type this all in on your calculator in one fell swoop, you need to put parentheses here, order of operations.
Wait, how did you go from 2x ln e to 2x.
Okay, here,
Oh, I see.
the ln and e cancel out.
Is the e canceled? Okay, yeah.
Yeah. Okay, so let's see, let me try to demonstrate -4 ln 3 divided by parentheses 2 minus ln 3. Okay, see how I put parentheses there? See if I can show you on the same screen. -4 ln 3 divided by parentheses. See, if you don't put the parentheses, then by normal order of operations, right? The calculator is going to think, oh, division, subtraction, I'm supposed to do division first, and you get a different answer. So it's got to be parentheses 2 minus ln 3. There it is, -4.875, whatever. Okay. On something else, on some of your calculators, when you hit the ln, it automatically pops up with a left paren. Mine doesn't. See, when I hit ln, it just gives me that. But some of you, it automatically gives you that. Okay, so once you hit ln, it gives you that. So you folks will have to close it with a right parenthesis, like that. Same for all the other functions. Okay, if your calculator does that, it'll probably do that for square root and sine and cosine and so on, right? Okay, so for my calculator, I could just hit sine, but some of your calculators, once you hit sine, it automatically goes like that. Then you folks have to close it. Okay, so I don't know, sine pi over 2 or whatever. Sine parentheses pi over 2. Whoops. Try to get this thing to focus, but I'm not. Anyway, sine of pi over 2 is 1. The calculator says 1. Okay, all right, there we go. Whoop, maybe not. Sine of pi over 2. Use this one. This one was in degree mode, which I don't want. Now I'm in radian mode. There's that. Okay, but I digress. Do just a few more, and then that's about it. Okay, 2 times 3 to the negative x equals 2 to the 3x. 53. Ignore any dates. Okay, divide by 2. 3 to the negative x equals 2 to the 3x minus 1. Okay, we have a rule that says I can subtract to 3x minus 1. Now take the natural log of both sides. This is very close to question 3 in the quiz. Okay, you got 3 to the negative x, 2 to the whatever, 3x minus 1. And in the quiz, you have something like that. Like in the quiz, you have a 2 and a 3 also. So very similar. So ln both sides, ln. Once you have the ln, these exponents come down. Negative x ln 3, 3x minus 1 ln 2.
Wait, what rule changes 3x minus 1?
I'm sorry, I didn't get the question.
What rule changes 3x to 3x minus 1?
I'm dividing here. 2 to the a divided by 2 to the b is 2 to the a minus b.
I see. I see.
Yeah.
Yeah.
Okay. So now it looks like this. That's very much like the quiz. And I think the quiz even had base 2 and 3. But anyway, ln both sides. Then this exponent comes down. This exponent comes down in parentheses. Well, this one you don't need parentheses because you're not adding or subtracting anything. This one you definitely want parentheses. Okay. Yeah. Pretty much the same. Okay, distribute 3x ln 2 minus ln 2. Okay, I want to have as few negatives as possible. I can subtract this over. If I subtract this over, I have a negative, negative, negative. I don't like all those negatives. So I'm going to move this guy over here. And move this over here, and now they're all positive, right? If I add ln 2, positive. If I add x ln 3, all positive. I like all positive better than all negative, right? So the trick is all the x's on one side, everything that doesn't have an x on the other side. Now you factor out the x and divide by this factor. So x is ln2 over 3 ln2 plus ln3. Okay, this is considered the exact answer. I want the exact answer. And then your decimal approximation, 0.2181. And there we go. Okay, let me actually try to show that to you. And I'll type it assuming those of you that have a calculator that automatically pops up with the left paren, how you would, folks would type that in. So divided by parentheses 3 ln 2 plus ln 3. And it's a 0.2181. Oops. Doesn't want to focus for me. Okay, if you have a calculator where you hit ln, it automatically gives you the left parenthesis, right? Then you have to close it with a right paren. And I have a double right paren because I have left, left, so right, right. So all of this right now is the numerator. Divided by parentheses, 3 ln, if your calculator gives you a left paren, then 2 right paren, plus ln, same thing, paren, 3 paren, and the second paren is to close the entire denominator. So this would be typed in like this, 0.2181. Okay, so there we go. All right, so hopefully that will help you with what we have on the quiz. All right, folks, the only other thing I have left are graphs of log functions. I can save that for Monday. So I have a little bit of 5.3 and all of 5.4 left next week. So I think it's okay for me to stop here. I didn't give you any graphs on this quiz. So the only thing you may not be comfortable with are the graphs at the end. So I think I've covered everything up to 53-ish. So next time I can do these graphs at the end, 55 to 65. Okay. So after that, I would be done. And even if I take all of Monday to do that, I still have Tuesday, Wednesday, Thursday, just to knock off one more section. We only have one more section, 5.4, leading up to the exam, which is next Friday. Okay. All right, so I think I've given you enough to do the quiz, and I'll let you get started on that. It's due at 11:59 p.m., so you have more than half a day to do it, open everything. Some of you, of course, aren't with me right now. You're joining by video later, so you have a little bit less time, but still should have plenty of time. Okay, so I'm going to stop, and I'll check the chat, and if there's nothing else, I'll just let you all go. So we put our calculator on radian mode when doing these problems. It doesn't really matter right now because we're not doing any trig. So either mode is fine. In fact, you don't need to worry about degrees or radians anymore until the final exam. We're not doing any trig now. The next chapter, our last chapter, we're not doing any trig either. So yeah, either mode is fine. Okay. All right, so any other questions? Otherwise, I'll let you loose to get started on the quiz. All right, folks, so go ahead and get started on the quiz. Have a good weekend. Have a nice Veterans Day, and we'll see you next time.
Thank
All right,
you.
bye, everybody.
Thank you.
Thank you. Bye.